Welcome back to Topic 7 for Algebra 2, Writing Linear Equations. In Part 2, we're going to focus on how to write a linear equation based on some given information. So, based on if we have a slope, m, or a y-intercept, b, we're going to use slope-intercept form. Also known as y equals mx plus b. M is your slope, and b is your y-intercept. Now, if we're given a slope and a point, we can use something called point-slope form. This is y minus y1 equals m times x minus x1. And here, our point is x1 comma y1, and then our slope is our m right here. Our y and our x that don't have any subscripts, they just stay, just like if we keep our x and our y when we're dealing with our slope-intercept form. Now, if we're given a point, or I should say 2 points, x1, y1, and x2, y2, then we're first going to calculate the slope, which we learned about in Part 1. Change in y over change in x. And then we're going to either plug into slope-intercept form or point-slope form. Okay. Now we're given a graph and we're asked to write an equation. So if we zoom in a little bit on our graph, we see we want to look for our slope and our y-intercept. We can see our y-intercept is at 4 at the point 0, 4, because this is where our line crosses the y-axis, so it's our y-intercept. Now, in order to determine the slope, we're just going to choose another point that is pretty easy to read. I like to choose one on an axis if possible. So we can choose this one, which is on the x-axis, and we need to calculate our slope. Our slope is going to be our rise over run. So how much does it take for us to rise up to that point? We're going to rise positive 4, because we're going up 4 units, and over to the right. Now this graph goes by units of 2, so it's going to be over to the right 2. So our slope is going to be positive 4 over positive 2, which reduces to just 2. And then we have our y-intercept at 4. That's our b value. So we can write our equation of the line. We have y equals mx plus b, which gives us y equals 2x plus 4. Now, sometimes we're already given explicitly our slope and our y-intercept, so we're going to plug that into y equals mx plus b, and we get y equals 3x plus 1, just direct substitution there. Example 3, we have to write an equation of a line that passes through a point and has a slope. So we could do this one of 2 ways. We could use point slope because we have a point and we have a slope. Or we could use this point and slope and apply it to slope-intercept form as well to kind of identify that slope-intercept. So we're going to do both ways just for practice. On the left, we'll do point slope, which is y minus y1 equals m times x minus x1. So we just plug in. We get y minus 4, because again, that's our y-coordinate, equals our slope of negative 3 times x minus our x1 is 5. And that's it. We literally do not need to multiply anything. That's just as is. If we wanted to write this in slope-intercept form, we can set it up using our slope, so y equals negative 3x plus b, and in for x and y, that's where we plug in our point. So 4 in for y and 5 in for x. We get 4 equals negative 15 plus b, add 15 to both sides, and we get b equals 19. So our equation is y equals, we're going to use this one from up here and just replace our b, negative 3x plus 19. Here we have an example that involves 2 points. So what we first need to do is we need to calculate our slope. Our slope, remember, is change in y over change in x. So we can label this x1, y1, and x2, y2, if that makes you feel more comfortable. So we want y2 minus y1, which is 10 minus a negative 2, over x2 minus x1, 2 minus 5. A negative times a negative is a positive, so we get 10 plus 2, which is 12. 2 minus 5 is negative 3. This reduces to negative 4. We could write this in point slope form. Let's just get a little bit more practice with that. So since we have 2 points, we can choose either for our final answer. We have y plus 2, or y minus a negative 2, equals negative 4 times x minus 5, or we can have y minus 10 equals negative 4 times x minus 2. Now in part 1, we referred back to parallel and perpendicular lines. So let's just remember that parallel slopes, they are the same slope. Whereas perpendicular slopes, it's the opposite reciprocal. In example 5, we're asked to write an equation of a line that passes through a point, negative 2, 3, and is parallel to, or in part B, which is perpendicular to, the line y equals negative 4x plus 1. So we have our line, we have our point. In part A, we want to write the equation of a line that's parallel, and part B, the equation of a line that's perpendicular. Let's start off with part A. So if it is parallel, we're going to have the same slope. Our slope here is negative 4. Now remember, this is really negative 4 over 1. 1 is a humble number. It's not always written, but it is there. So that's actually in our denominator. That will come in handy later, so I'm just going to mark it for now. Now we can mark that with the point. We could do it in point slope form, or we could do slope-intercept form using our given point. So we could have y minus 3 equals negative 4 times x plus 2. Or we could plug in and find our y-intercept. So y equals negative 4x plus b. In for y is 3, in for x is negative 2. We get 3 equals positive 8 plus b. b is going to give us negative 5. So our answer here would be y equals negative 4x minus 5. So these are our two answers here. Now if we want to do the same thing, but for a perpendicular line, then a perpendicular slope is going to be the opposite reciprocal. So we're going to change the sign. It's now going to be positive, and flip our fraction. So now we have 1 over 4. If we want to plug in with the point, we get y minus 3 equals 1/4 times x plus 2. Or again, we can plug in if we want more practice. We would get y equals 1/4 x plus b. In for y is 3, in for x is 2. So we get 3 equals 2 times 1/4 is 2/4, or 1/2, plus b. b ends up equaling, I'm sorry, this is a negative 2. b ends up equaling 7/2, and our equation, if I just write it over here, gets to be y equals 1/4 x plus 7/2. And there we go. That was part 2 of topic 7 for Algebra 2. Thank you for watching.